Good evening, Pute. Right? Today we have to discuss the rest of the chemistry part that we have discussed last day. Right? Last Sunday we discussed 40 MCQ questions from the O-level past papers. Right? So today we have to discuss the rest of the MCQ paper and the essay and structured questions. Right? So we have to start from 41. Right? Right, this is the paper we have discussed up to 40. Right here, Pute. Right. So from 41 we will discuss. Right. I think that already you have marked the answers. Right. As I told you last day, right, we have to gather the subject content when we are doing the MCQ questions. Right. That is the very easiest way to recall our memory about the subject content, right? Okay. Right. Now go through the question number 41, Pute. 41, right? Given below are 4 ways by which zinc, metal and hydrochloric acid were reacted at room temperature, right? What is the reaction between the zinc, metal and the hydrochloric acid, right? In which way is hydrogen gas liberated with the highest speed, right? With the highest speed, right? So what is the reaction is, it is between the zinc metal and the hydrochloric acid, right? We are given 4 answers, right? We have to select when we use which reactants in which status, right? It can get the hydrogen gas with the highest speed, Pute, right? So when we recall our memory, right? Question number 41, right? Here it is the question number 41 is regarded with the what? The rate of reaction, right? So as we discussed in the theory part, right? What are the factors that affect to the reaction rate, Pute? Yes, what are the factors? The physical state, or we can say the surface area of reactants, right? And the concentration of reactants, right? And the temperature and the catalyst, right? So those are the factors that affect to the reaction rate, right? So here the 2 reactants used is here zinc metal and the hydrochloric acid. So zinc metal, when we consider the zinc metal, right, the physical state, or we can say the surface area of zinc metal affect to the reaction rate, and the other one hydrochloric acid. So in hydrochloric acid, the concentration is affect to the reaction rate, right? So we know if the surface area is high, the reaction rate also high. And if the concentration is high, or when we use concentrated ones than the dilute ones, right, the reaction rate will be high, right? So we have to select the answer regarding that one. Zinc granules and dilute hydrochloric, zinc granules and concentrated hydrochloric, zinc powder, dilute hydrochloric, zinc powder, concentrated hydrochloric. So Pute, when we use zinc powder, it has more surface area than zinc granules, and when we use concentrated hydrochloric acid, right, the reaction rate will high. So the answer should be the 4th one, zinc powder and the concentrated hydrochloric. So here the surface area affect to the reaction rate, and the concentration of the reactants affect to the reaction rate, right? Look at the 42. The hydrocarbons contained in LP gas as its major components. Major components. we know about hydrocarbons, right? There's a essay question, right? In the second paper, we will discuss it. That is about the hydrocarbons and how we extract them, right? So here, the hydrocarbon LP gas, right? It contain only hydrogen and carbon, hydrocarbons, right? What are the major components in LP gases? Yes, propane and butane, propane and butane. Second answer, Pute. Second answer, right? 43. Which of the following is equal in K 43? Right? What are the two elements given here is potassium 1940 and calcium, right? 20 and 40. Right? When we consider these two, Pute, when we get the number of protons, that is the atomic number. This is the atomic number and this is the mass number. Atomic number means the number of protons here. Number of protons. The mass number means the sum of the protons and neutrons. Right? We know all these things. Right? So here in potassium, number of protons 19. Here it is 20. Right? When we consider the electrons, normally the atoms in the elements are electrically neutral. Right? You have to remember these terms, Pute. When you write the answers for the structured paper or the essay paper, you have to use these terms, right? Because the marks are given for those things, right? As the atoms of the elements are electrically neutral, the number of protons and the number of electrons are equal, right? So here 19 electrons and here also 20 electrons. When we get the number of neutrons, this is the mass number and the atomic number, right? Sum of protons and neutrons and the number of protons. Then neutron means here 40 minus 19, right? Here 40 minus 20, right? Here what is the answer? 21, here 20, right? Now we can select the answer. Which of the following is equal, Pute, right? Number of electrons, is it equal 19 and 20? No, wrong. Number of neutrons, 21 and 20. No, that is wrong. Sum of the number of electrons and protons. Sum of the number of electrons and protons. No, 19 plus 19, 20 plus 20. That is wrong. Sum of the number of protons and neutrons. What is that, Pute? Protons and neutrons. That means this one. The mass number. Yes, the mass number is equal. Right? Mass number is equal. Right? So, what is the answer? Fourth one. Right? Then 44. How much is the mass of sodium chloride contained in how many? 100 cubic centimeters of a sodium chloride solution of concentration is given 1 moles per cubic decimeter. Right? We have to do the calculation, Pute. Right? The concentration of the sodium chloride solution is given. Right? Question number 44. Concentration is given, Pute. That is 1 mole per cubic decimeter. Right? 1 mole per cubic decimeter. The relative atomic masses are given. We have to find the mass, right? So here, right, 1 mole containing 1 cubic decimeter, Pute. 1 cubic decimeter means, right, I told you last day also, that is 1000 cubic centimeters, right? So, in 1000 cubic centimeters, right, it contain 1 mole, Pute, right? 1 mole. Then they have asked in how many? 100 cubic centimeters. In 1000, 1 mole. Then in 100, right? I am doing these calculations. That is for the structured or the essay paper, right? So, what is the answer here? Yes, that is 0.1 moles, Pute, right? 0.1 moles. right? What is the question is, how much is the mass of sodium chloride? Then we have to convert this into what? Mass, right? So before that, we have to calculate the, yes, relative molecular mass of sodium chloride. 23 plus here 35.5, right? If it is the structured or the say paper pute, you have to do this one also in the paper, right? Not in the rough paper, right? You have to remember that one. Yes, what is the answer? 58.5, right? So this is the relative molecular mass, right? Then we have to calculate the mass. We know this relationship, number of moles equal mass divided by the, yes, relative molecular mass, right? We have to find this one pute, mass, then cross multiplication of this, then mass equals the number of moles into, yes, molar mass, this one when we get the molar mass, right? So here number of moles 0.1, then this one 58.5. Yes, then what is the answer pute, right? We have to take another decimal point here to the left side, right? 5 point multiplying by 0.1 means dividing by 10, 5.85 grams, 5.85 grams. What is the answer pute? Third one, right? So it can be given the questions like this for the structured paper or the essay paper also, right? So step by step you have to do the calculations in this way, right? And you have to write the sentence here also. If it is here, right, number of moles contained in 100 cubic centimeters, right? Then you have to do this one, that is 0.1, right? According to the marking scheme or the allocated marks, you are given 1 mark for this one, right? Then you have to do this calculation, another 1 mark for this one, right? Then another for this one, and this one another 1 mark, and for this one another 1 mark, right? That is according to the allocated marks pute, right? This is only an example, right? That is why I told you step by step you have to do the calculation, right? If it is in the essay or the structured paper, right, then it is very easy to get the marks, right? Then 45, what is the number of carbon dioxide molecules in 22 grams of carbon dioxide? Right, we do these types of questions in last day also. What is the number of carbon dioxide molecules in 22 grams of carbon dioxide? Right, I will erase this one, right? Forty-five. Right, what is the question? What is the number of carbon dioxide molecules in 22 grams of carbon dioxide? Right, the Avogadro constant also given, right? Yes, what we know is, right, in 44 grams of carbon dioxide, right, 44 grams of carbon dioxide, it contains how many molecules pute? How many molecules? Yes, Avogadro number of molecules, right? In 44 grams of carbon dioxide, it contains this number of molecules pute, right? This number of carbon dioxide molecules. What is the question here is in 22 grams, right? In 44 grams, it contains this number 022 into 10 to the power 23. Then in 22 grams, right? If there are Avogadro number of molecules in 44 grams, then in 22 grams. That means half of this one. Yes, then what is the answer, right? No need to get the answer, right? This step is given for you, right? 44 here, 20, they have written 22 here into 6.022 into 10 to the power 23. What is the answer, Pute? First one. First one. Right? Right? You have to remember this relationship, right? Very easy, right? When we take the molecules, the mass of any molecules, that is equal to the what? Relative molecular mass in grams. It contains Avogadro number of molecules. Avogadro number of molecules, right? Then you can get the relationship, right? Then 46, Pute. The chemical formula of the chemical fertilizer urea is given, right? Select the correct statement about urea. Urea possesses the properties of the constituent elements. Right? What are the constituent elements here? Carbon, oxygen, nitrogen, and hydrogen. Right? They combine together and form urea. Separately, carbon has different properties, oxygen has different properties, nitrogen and hydrogen, they have different properties. They have unique properties for those elements. But when they combine, Pute, right, when they combine to form urea, right, then urea has some other properties, right, that is not equal to those properties of the elements. Right? So, urea possesses the properties of the constituent elements. That is wrong, Pute. Right? Look at the second one. A molecule of urea has 2 carbon atoms. 2 carbon atoms. No, that is wrong. Only 1 carbon atom is there. Right? Look at the third one. A molecule of urea has 4 hydrogen atoms. Yes. 2 into 2, 4 hydrogen atoms. That is correct. We will check the fourth one also. The total number of atoms in a urea molecule is 7. Right? 1 carbon, 1 oxygen, 2. How many nitrogen is there? 2 nitrogen. Then altogether 4 atoms and 4 hydrogen. Then altogether how many? 8 atoms are there, Pute. In one urea molecule, there are 8 atoms. So the fourth one also wrong. Then what is the correct one? Third. Then look at the 47. Some information regarding an element are as follows. Right? What are the information? Has several allotropic forms. One allotropic form conducts electricity. Right? That is the hint. That is the sentence that where we can get the idea. One allotropic form conducts electricity. Right? Here, according to our syllabus, right? According to our syllabus, only we discuss about 2 elements that has allotropic forms, Pute. Yes, one is sulfur and the other one carbon, right? So if you are given the sulfur here, what can be given, right? It is in yellow color, right? And when we burn it, it gives a blue color flame or unpleasant smell, right? Like that, the sentences can be given. But here has several allotropic forms. Then we get maybe sulfur or carbon. Then look at the second one. One allotropic form conducts electricity, right? Sulfur is a non-metal, so it should be carbon. What is that, Pute? One allotropic form that conducts electricity. Tell me, what are the 2 allotropic forms of carbon? Yes, diamond and yes, graphite. Diamond and graphite. So, which one conducts electricity? Diamond or graphite? Yes, graphite, right? So, this element is carbon, right? If you have asked the allotropic form, that should be graphite, right? And diamond is the hardest material. We use diamond to cut glass, right? You have to remember all these things. 48. When thin iron wool is heated, it instantly burns. But though an iron nail is heated till red hot, it does not undergo a considerable change. What conclusion can be drawn from these observations? Right? When we heat iron wool, instantly it burns, right? But when we heat an iron nail, it get red hot, right? But there is no considerable change. Only it get heated, right? Ah, then what is the conclusion here? Iron wool acts as a catalyst, right? Iron wool and iron nail undergo reactions different from each other. The composition of iron wool and iron nail is different from each other. And the fourth one, the rate of reaction depends on the physical nature of the reactants. Yes, what is the answer, Bhute? Fourth one, both iron nail and iron wool is same, the same element, same metal. But what is the difference is here, the physical nature. Iron wool and iron nail, the physical nature is different, the surface area, right? So, what is the answer is the fourth one, right? 49. Which of the following statements is false about electroplating of iron, Pute? Electroplating of iron. It is regarding with the grade 11 part, right? Never mind, right? We will see. First one. An aqueous solution of a compound of the metal that is electroplated should be the electrolyte, right? I don't know whether you complete this electrolysis lesson or not, right? It is in the third term, right? So if we want to plate any metal on iron or anything, right, we have to use a solution, an aqueous solution, right, with the metal that we want to plate as the electrolyte. Electrolyte, I think that you can remember, Pute. Electrolyte means the solution that we use. Here, this one, electrolyte, right? Look at the second one. The electrolyte should be in high concentration for quality electroplating, right? We will see. Look at the third one. Iron should be made the cathode of the electrolytic cell. No, the metal that we want to apply, right? The metal that we want to apply should be made as the cathode, Pute, right? So iron should be the anode here. The current used should be a direct current. The current used should be a direct current. Yes, yes. Sorry. The third one correct, right? And the fourth one also correct. The current should be a direct current. Yes, not an alternate one. We have to use the direct. We use the batteries, right? So it gives the direct current, Pute. Yes, what is the false one? The electrolyte should be in high concentration. No, the electrolyte we use here should be in low concentration for the quality plating. Then only the metal that we want to apply on the iron nail, right, plated properly, right? When we use the electrolyte in with low concentration, right? So the false one is the second one, right? 50. A conical flask containing aqueous hydrochloric acid is kept on a sensitive balance, right? Piece of limestone were added to it in excess amount, right? Excess amount. Which of the following graphs indicates how the balance reading varies against the time after adding of limestone, right? Not before, Pute, after adding of limestone, right? What happens here? The reaction between the limestone and the hydrochloric acid, right? There's a balance here, right? Balance here, and the conical flask is there. 50, right? Conical flask is there, and aqueous hydrochloric acid is here, right? So what we are doing is we add limestone, right? We add calcium carbonate in excess amount, right? We put here, right? Then after adding, what happens here? The reaction starts, right? The reaction start between HCl and what? Calcium carbonate puthe, right? So after adding of calcium carbonate, right? After adding of the calcium carbonate, right? Maybe the reading is shown in the balance, right? So when these two, HCl and calcium carbonate reacts together, now after adding calcium carbonate, now the reaction starts puthe, right? Then what happens, right? What happens? The varies against after adding of limestone. Balance reading. What happens to the balance reading, right? So what happens here? What are the products formed here, right? If all the products formed here remain in the conical flask, there is no change in the mass or the weight, right? But here, as a product, between the reaction of calcium carbonate and HCl, it produce what? Carbon dioxide gas puthe, right? Carbon dioxide gas. So what happens here is carbon dioxide gas liberate here or removes from the conical flask. Then what should happen here is, yes, what happens to the mass or the balance reading? Yes, it should reduce, right? The balance reading reduce gradually, right? That means the mass or the weight reduce gradually. That is due to the releasing of the carbon dioxide, right? Then what happens? We add calcium carbonate in excess amount, but only a limited amount of HCl is there puthe, right? Then after all the HCl react with calcium carbonate, it produce carbon dioxide, right? Then up to that, the balance reading reduces. Then it remains only the excess amount of calcium carbonate in the conical flask, so that the balance reading remain constant. Balance reading remain constant, right? After adding calcium carbonate, the reaction starts and it liberates carbon dioxide gas, right? So that the balance reading decreases, and after using of the whole amount of HCl, it remains only the excess amount of calcium carbonate, then the balance reading remain constant. So what is the answer, Pute? Fourth one, right? Then 51. Select the correct answer or the select correct statement, Pute, right? About atoms, right? The nucleus of all the atoms of every element contain neutrons. Is it correct, Pute? The nucleus of all the atoms of every elements, right? If you are given these statement type questions, you have to concern about these words, Pute. Only, always, every, like that, right? So here, the nucleus of all the atoms of every element contain neutrons. Is it correct, Pute? Is it correct? No. Why you say like that? Can you give me one example without neutrons? Without neutrons? Yes. Can you remember the three isotopes in hydrogen? Protium, deuterium, and tritium. Protium, deuterium, and tritium. In protium, no neutrons, Pute. Right? No neutrons. So that is wrong. Look at the second one. In every atom, there you can write that one, right? Protium. As an example, if you have asked a question like that in the coming year, right? In every atom, the number of neutrons and the number of protons in the nucleus are equal. Is it correct, Pute? No. The number of neutrons and the number of protons, no, that is not equal, right? Then third one, the atomic number of two atoms of different elements can be equal. Atomic number No, Pute. Atomic number is a unique feature for each and every element. It is something like our identity card, right? I have an identity card that is only for me, right? Same way, all the elements have the unique feature, something like our identity card, that is the atomic number, right? It is not equal. The atomic number of two atoms of different elements can be equal. No, that is wrong, Pute. Look at the fourth one, right? Fourth one. There may be atoms with different mass numbers in the same element. Yeah? What is that? There may be atoms with different mass numbers in the same element. What are they, Pute? How we name them? Yes, as isotopes. That is correct, right? Atoms in the same element with the same atomic number but with different mass numbers. They are isotopes, right? So the correct answer is the correct statement is the fourth one, Pute. Right? Look at the 52. M. Right? It is not a standard symbol. Plus zinc sulfate, M sulfate plus zinc. In the above chemical equation, the metal indicated as M could be M. Right? So what is this one, Pute? What is the type of this question? The reaction? Yes, we know there are four types of chemical reactions. Four types of chemical reactions. What are the four types? Chemical combination, chemical decomposition, yes, single displacement and double displacement. The four types of chemical reaction. So this belong to, yes, this belong to 52, Pute. M plus zinc sulfate, M sulfate plus zinc. Right, I'm not writing the physical states, right? So here, what happens here is zinc was displaced by M, right? Zinc was displaced by M. To do that, M should be more reactive than zinc. M should be more reactive than zinc, right? Then we have to remind the activity series. Yes, activity series. For yes, right? So zinc is here. This, the element should be a metal, yes, just above the zinc. Yes, what is the answer, Pute? It should be magnesium. It should be magnesium. Then the third answer, right? What is this type chemical reaction? It is single displacement, right? Single displacement. You have to remember all these things. Single displacement, right? To do this one, this M or the metal that we add should be a more reactive one than the metal in the salt or the solution, right? So, and here that if the, right, if the reaction is this one, Pute, right, magnesium plus copper sulfate, that means we add some pieces of magnesium, right, into a copper sulfate solution. What is the color of copper sulfate, Pute? Right? Yes, that unique blue color, right? So when we add magnesium into this one, the copper displaced by magnesium, then it forms, yes, magnesium sulfate and copper displaced, right? Copper displaced. So what are the observations you can collect here? Yes, if the reaction is this one, Pute, this is same as this one, this type, single displacement. Yes, what are the reactions? Sorry, observations. Yes, I told you that copper sulfate is blue color. You know that one, right? So when we add more and more magnesium to the copper sulfate solution, yes, the blue color of the solution, yes, blue color reduces. Blue color reduces. Or you can say the very correct answer, The blue color of the copper sulfate solution gradually reduces, gradually decreases, right? That is one. Observations, Pute, right? Then what is the other one? Here, the displaced copper deposit at the bottom. Displaced copper. Can we write copper for the observations? No, Pute. Only we can write brown color powder. Right? Brown color powder deposited. Right? Brown color powder deposited. Right? So those are the observations. Observations, right? What we can observe here is then after writing the equation, then we can conclude, yes, that is copper. Right? It is okay. But here, these are the two observations. Right? So it can be given a question in this way, right? Regarding this one. Right? 53. It is regarding with the former one. What is the type of reaction to which the above equation belongs? Yes, single displacement. Single displacement. Right? 54, there's a calculation put there. Right? You have to remember these things. Right? There's a small calculation. Of the following compounds, what is the compound in which the percentage of oxygen by mass is 50%? Right? Out of the given compounds, Pute, we have to select in which one it has 50% of the total mass, right? The mass of oxygen, right? The mass of oxygen should be 50%. That means half of the total mass, right? We will see. Look at the first one. That is ammonium hydroxide. Ammonium hydroxide. Second one, calcium hydroxide. Third one, CH3OH. What is fourth one here? Magnesium carbonate. Right? First, we have to get the relative, just relative molecular mass of these four, Pute. That is why you are given the relative atomic masses. Right? If it is ammonium hydroxide, I think you have find the answers, right? Relative molecular mass 25. 25. Here only one oxygen, that means 16. Is this half? No. Right? So not this one. Right? Here in calcium hydroxide, what is the molecular mass? It is 74. And here how many oxygen? Put there 2 oxygen. 2 atoms are there. Right? That means 32. 32. Right? Is it half of the total mass? No. Then this one, CH3OH. What is the total mass? 32. Right? 32. How we get it? 12 plus, here 3 hydrogen, 3 plus, here oxygen, 16 plus 1 pute, right? 32. Then only one oxygen here, then 16. Yes, simplify this one. That is half, that means 50% of the mass it contain oxygen. Right? So the answer is the third one. We will check the fourth one. Magnesium carbonate, it is 84. Right? Then 3 oxygen atoms are there. That means 16 into 3 pute. That means 48. No, that is also wrong. So the answer should be the third one. That is how we find. Right? Look at the 55. What is the statement that is true with respect to all the molecules given below, right? All the molecules. What are the molecules here? Carbon dioxide, ammonia, and water, right? The electron octet of the central atom of the molecules is complete. The electron octet of the central atom, right? Central atom, the atom in the middle of the molecules is complete. We will see, right? Only single bonds occur among the atoms of the molecules. Only single bonds. We have to consider all the three pute. Carbon dioxide, ammonia and water. No, that is wrong. No. In carbon dioxide, there's a double bond, right? In carbon dioxide, there are two double bonds. So the second one is wrong, right? Then look at the third one. Lone pairs of electrons are present on the central atom of the molecules. Central atom, right? That should be correct to all the three, Pute. Right? First, we will draw it, right? 55. You have to be very concerned about the Lewis structures, dot cross diagrams, and all these things, right? Carbon dioxide. Right? There are two lone pairs here, right? Carbon dioxide. And ammonia, NH3, right? Nitrogen is the central one, and there are three hydrogen atoms. One lone pair. Yes, any question, Pute? Any question? No. Right? Then water. Right? The central atom oxygen and the two hydrogen and two lone pairs here. Right? So, only single bonds occur among the atoms of molecules. The second statement wrong because there are double bonds here. Right? Lone pairs of electrons are present on the central atom of the molecules. No, here the central atom is nitrogen, there is a lone pair, right? Here the central atom is oxygen, yes, there are two lone pairs, but here that is wrong, Pute. Carbon is the central atom and no lone pairs in carbon, right? Then third one also wrong. Look at the fourth one. The molecules exist only as gases at room temperature, right? This one okay, carbon dioxide gas, this one okay, but this is in the liquid form of water, right? So the fourth one also wrong. Then what is the correct one is the first one. The electron octet means 8 of the central atom of the molecules is complete, right? Here 1 2 3 4 5 6 7 8 for carbon, right? Here 1 2 3 4 5 6 7 8 for nitrogen. Here 1 2 3 4 5 6 7 8 for oxygen, right? Then the first one okay, Pute. So the answer is the first one. Look at the 56. What is the amount of moles in oxygen in 64 grams of oxygen? 64. We know in 32 grams, right? In 32 grams of oxygen, right? 56. I will write here. 32 grams of oxygen means 1 mole, Pute. Right? We know that one. Then in 64 grams, right? Twice of this one, then it contains how many? 2 moles. Right? Very easy. Second answer. What is the mass of glucose here? C6H12O6 required to prepare 1 decimeter of a 1 mole per cubic decimeter glucose solution. Right? The concentration is given. Right? The concentration of the solution that we are going to prepare is given. Right? The concentration is 1 mole per cubic decimeter. $57, Pute. Right? The concentration is given 1 mole per cubic decimeter. Right? This is the solution that we are going to prepare. Right? What is the mass of glucose required to prepare 1 cubic decimeter? Right? The volume is same. 1 cubic decimeter. In 1 cubic decimeter, it contains 1 mole, Pute. We have to convert it into mass, right? Glucose, C6H12O6, right? The relative molecular mass or the molecular mass is 180 grams per mole, the molar mass, right? That means in 1 mole, it contains Yes, this number of grams, right? Sorry. Here 0.1 pute, right? 0.1, right? The molar mass of glucose is 180 grams per mole. That means in 1 mole, it contains how many grams pute? 180 grams. Then in 0.1 mole. Yes, we have to divide this by 10, right? As here. Then, what is the mass? 18 grams. This is the relationship. 18 grams. What is the answer, Pute? Third one. Third answer. Look at the 58, right? A question from the previous exam, 22. Arrangements A, B, C, and D set up by a student in the laboratory using 4 clean iron nails to study about corrosion of iron are as follows, right? The 4 setups are given here, A, B, C, D. In A, iron nail is dipped in sea water, and in B, in vinegar, and C, right? It connected with the conducting wires with a zinc plate, right? And in distilled water, right? In D, it is connected with a copper plate and dipped in distilled water. Yes. What do you know about corrosion of iron, Pute, or rusting of iron? Yes, when we consider the rusting of iron, yes, acids and salts. Acids and salts increase the rusting rate. Acids and salts, they increase the rate of rusting. So here in sea water means totally salts and vinegar, acid, right? So in A and B, the rusting rate increases, right? We have to select the iron nail with the has corrode least, right? So in A and B, right, the 2 iron nails get rusted more. Look at C and D, Pute. Right? In C, iron nail is connected with the zinc plate. That means with the metal more reactive than iron. More reactive than iron. But in D, iron is connected with the copper plate. Copper is less reactive than iron. Right? So what happens here is zinc plate in C, right? As I told you, seawater and vinegar, right? They increase the rusting rate, right? So in C, what happens here? Zinc is more reactive than iron, right? So zinc here, zinc act as the cathode, right? Zinc act as the cathode and release electrons and form Zn2 plus ions, right? How we name this incident? Yes, right, this one we name as cathodic protection. Cathodic protection. When we keep iron with the metal, right, with the metal that has, or with the metal of more reactive than iron, it that more reactive metal act as the cathode and prevent the iron from rusting, right? Here it gives the cathodic protection, right? So the answer should be the third one, Pute, C, right? In D, copper is less reactive than iron, so iron get rusted, right? So the answer should be the third one. What is the incident here is cathodic protection, right? Cathodic protection. 59. What is the chemical compound that ionizes completely in aqueous solution and releases H plus ions, right? We discuss more questions regarding this one. Yes, ionizes completely, right, in the aqueous solution. In the aqueous solution, only the strong acids and strong bases ionize completely. So what is the answer, Pute? Fourth one, HNO3. HNO3, the strong acid, right? Sixth one, which option indicates the chemical species affecting environmental crisis? What are those? Ozone layer depletion, acid rains, And eutrophication. Eutrophication, this is also regarding with grade 11 one, right? Never mind. Ozone layer depletion, acid rains, and eutrophication. What is the answer, Pute? Respectively, right? We have to select in order. Ozone layer depletion, CFC. CFC, chlorofluorocarbon. First and second answer, right? Then the second one, acid rains, right? Sulfur dioxides or the oxides of nitrogen, right? Then first one, second one also correct. Then we have to select according to the third one, eutrophication. Eutrophication due to the ions of, yes, nitrates and phosphates. Right, you will find these things in the last lesson of grade 11, right? So the answer should be the second one, Pute. Ozone layer depletion, CFC, acid rains, sulfur dioxide, and eutrophication, nitrate ions. Nitrate ions. Answer should be the second one, right? So we have complete that one, right? We discussed 60 MCQ questions, right, from the papers of 16 up to 22, right? There may be some other questions, right? I have selected only these 60, right? Then we have to move to the other one, Pute, that I have sent for this week, right? For this week, the structured one and the essay paper, right? There are more structured and essay questions, right? Only I have selected these. This one, Pute, right? We will see. I want to practice you to how to answer these ones, right? That is why I have selected only few questions, right? As I told you, there are more questions regarding the grade 10 chemistry part, right? If you have complete grade 10 syllabus, right? Physics, chemistry, and biology, right? Without neglecting anything, right? If you have completely cover the grade 10 syllabus, right? You can obtain a B pass for the O level, Pute, right? B pass, right? So most of the questions are based on grade 10 part, right? Grade 10. So it is very important to cover the whole syllabus, right? And study each and every part. Then it is very easy to get a good pass. Good pass means very easily you can get an A pass for science, Pute, right? We will see this one, right? Very easy, right? I want to tell you that how we have to write the answer, especially in the structured paper, Pute. You are given a limited space, right? And remember, right, don't write the answers for the structured paper in the given separate paper, right? You can't do that one, right? The given space is enough, right? Enough to write the answer. So however, you have to write the answer in the given space, right? That is why you have to practice this one, right? We are not writing very lengthy answers for the structured paper, Pute, and also for the essay paper, right? Only we have to give the definite answer for the questions, right? So to give the definite answer, we have to practice that one, right? That is why the answer in the questions is very important, not only to studying the syllabus, right? So we have to practice more and more questions. Then very easily, if we look the questions very easily, the answer comes to our mind, right? Otherwise, we write something and we cut it again. We write something and we cut that one also, right? Then the space is not enough, right? Then we have to write here and there for the structured paper, right? So it is very important to practice for answering the structured questions, right? We will see. Look at the first one, Pute. Look at the first question. Right. All the elements belonging to second period, right? Second period of the periodic table are given below without following the correct order, right? The elements are not in order, right? So what is the question here is part 1, arrange all the above elements as in the periodic table. Very easy, Pute. Right? First one, part 1, right? The elements in the second period are given here. So we have to arrange them order. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon also there. Right? We have to write in order. Very easy, Pute. Right? Look at the second one. Write the electronic configuration of fluorine. Right? What is the atomic number? Yes, 9. Right? Then write the electronic configuration, the number of neutrons 9, then 2, 7. 2, 7. Then part 3. Write the chemical formula of the compound which is formed in the reaction between lithium and oxygen. Lithium and oxygen. Right? Lithium and oxygen. Right? If you have asked a question like this, Pute, it is better to write in this way, right? Write the valencies and exchange the valency numbers, then write. We don't know how they are given the marks in the marking scheme. So it is better to write in this way. Lithium, the valency 1, oxygen, valency 2, right? Then Li2O, lithium oxide, Li2O. What is the type of chemical bond present in the compound stated in A? Yes. What is Pute? Ionic bonds. Right? Ionic bonds are there. Right? Then fourth one. In the given box, draw the Lewis structure of carbon dioxide molecule which is formed with the combination of one carbon atom and two oxygen atoms. One carbon and two oxygen. Fourth one, I will draw here, Pute. Right? Very easy. You have to draw the Lewis structure of carbon dioxide molecule. Right? When we are drawing the Lewis structures to show the bonds, we use a short line like this to represent the bonds. And we have to represent the lone pairs using dots. No crosses in Lewis structures. You have to remember that one. And two lone pairs here, right? And another two lone pairs here, right? The Lewis structure of carbon dioxide molecule. Then look at the fifth one, Pute. Diamond and graphite are main allotrophic forms of carbon. Which of these allotrophic forms conduct electricity? Yes, what is the answer? What are the two forms, diamond and graphite? So graphite conduct electricity. Sixth one, from the elements in the period, in this period, right? That means the second period, Pute. Write respectively the element which has the lowest first ionization energy, and the element which has the highest electronegativity, lowest first ionization and the highest electronegativity. Yes, lowest first ionization energy we can find in the first group elements, first group, then it should be lithium, Pute, right? Lithium, you have to write respectively. And the highest electronegativity, yes, what is that one? Fluorine. Fluorine, lithium and fluorine. Yes, we will move to the second one. This is a part of a question, right? Not a whole question. The following questions are based on an experiment on producing a sample of oxygen gas in the laboratory, right? These are the questions, Pute. Among the compounds given below, which compound can be used to produce oxygen gas? What are the compounds given here? Calcium carbonate, potassium permanganate, magnesium sulfate. Just which one we can use to produce oxygen? Yes, potassium permanganate, KMnO4 pute, KMnO4. What is the type of reaction that take place during the production of oxygen gas when only the compound U stated above is used, right? That means when we use potassium permanganate, there are some other methods that we can produce oxygen gas, the decomposition of hydrogen peroxide, right? Like that. But here, when we use potassium permanganate, what is that reaction type, Pute? Yes, that is also chemical decomposition. Chemical decomposition. Potassium permanganate decompose into potassium manganate, manganese dioxide, and oxygen gas. You have to remember the chemical equation, right? Chemical decomposition. Which equipment must be used to place the compound? That means place the potassium permanganate to carry out the experiment. What is the equipment we use there? Yes, boiling tube. Boiling tube. Fourth one. What is the name given to the method that is used in the laboratory to collect oxygen gas produced in this experiment? Can you remember the setup, Pute? Right, we discussed these things. The preparation of three gases. The trough is there and the gas jar is here. Delivery tube is connected to here, right? Water here. And at the beginning, the gas jar is completely filled with water. When the air bubbles are coming, that means through the delivery tube, oxygen gas is coming, right? Then what happens? When the oxygen gas enter to the gas jar, the water level goes down. Water level goes down. That means the water goes down and oxygen collected here at the upper part of the gas jar, right? Water goes down. So we say downward displacement of water. Water displays down, Pute, right? Downward displacement of water, right? Downward displacement of water, right? Very easy. Look at the third one, right? The symbols of the elements in the second period again, right? Second period of the periodic table are given in the following table in respective order. Now, the elements are given in the order, Pute, right? Yes. Select the symbol of the element relevant to each of the following statements from the above table, right? We are given the standard symbols and they are given some statements. We have to select the correct elements regarding the given statements, right? Look at A, has the maximum first ionization energy, right? In all the periods, right? In which group? 8 group, or we can say the 0 group elements has the maximum first ionization energy. Then what is the answer, Pute? Neon here, right? Neon. You have an idea about the first ionization energy or how it changes or differs along a period. Normally we say along a period, the first ionization energy gradually increases, Pute, gradually increases, right? When we draw the table, graph, right, atomic number here, right? When we put the elements in this way, right? Normally, first, second, third, there's a gap. And fifth one, sixth one, there's a gap. And this way. That is why we say gradually increases. First ionization energy gradually increases, right? Second here, third here, fourth here, and fifth one here, sixth one here, right? And 7 here, 8 here, right? You have to know this sketch, Pute, the rough idea about the first ionization energy, right? Then look at the second one, has the minimum electronegativity. Minimum electronegativity. When we talk about the electronegativity, yes, there also we say along a period, electronegativity increases. along a period, electronegativity increases. So the minimum electronegativity we can find in the first group element. So what is the answer? Lithium. Lithium. Diamond is one allotropic form. Diamond is one allotropic forms in where Pute? In which one? Carbon. Carbon exist as diatomic molecules with a triple bond between the atoms. With a triple bond. Yes, only one we have with triple bond, but it exists as diatomic molecules with a triple bond. Yes, what is that, Pute? This is the diatomic molecule is nitrogen gas, and this is the triple bond, but the element is nitrogen. Nitrogen, right? Exist as diatomic molecules as well as triatomic molecules in the atmosphere. What is that? We can find only one regarding that one. This is D, E. Diatomic O2, right? And triatomic means O3, ozone. Yes. What is the element, Pute? Oxygen. You can't write O2 or O3, oxygen. Right? Oxygen. Because you have to select the symbol of the element and write it on the dotted line. Right? If you have written O2 or O3, no marks, Pute. ON2. Right? Only you have to write the symbol of the element. Right? Then write the formula of the compound formed by the combination of the elements lithium and oxygen. Same question is repeating. Same question, right? Again, lithium oxide, Pute. Right? Lithium, oxygen, 1, 2. Exchange the valency numbers, Li2O. From the ions given below, third part, from the ions given below, select the cation and anion which the compound formed by the combination of lithium and oxygen contains and underline them. Yes, what are the ions formed here, Pute? Yes, when it forms lithium oxide. When it forms lithium oxide, what is the anion form and what is the cation form? Yes, lithium, right? When we consider lithium, the atomic number 3. Electronic configuration 2, 1, right? It removes the electron in the last energy level and it forms, yes, what is the ion, Pute? Lithium plus ion, right? Lithium plus ion. When we consider oxygen, yes, 2, 6, right? It wants another 2 electrons to the last energy level, right? Then after obtaining the 2 electrons for the last energy level, it forms the ion O2 minus. O2 minus, right? So the 2 ions should be lithium plus ion and O2 minus ion. O2 minus ion. Fourth one, draw the structure of the simplest monomer. Simplest monomer. Monomer, that is the basic unit of polymers, which can polymerize and contain only the elements carbon and fluorine. Only the elements carbon and fluorine. Then what is the monomer, Pute? Only it contains carbon and fluorine. Here. Right? Yes. Then look at the fourth one. Again, the same things given below in a different way. Right? Look at the fourth question, Pute. The following figures indicates the lattice structures of 3 solid substances P, Q, and R. P, Q, and R. Identify them and fill the relevant blanks, selecting the names of those substances and the lattice structures from the box given below. Are the answers also given? We have to select the correct answer and complete, Pute. Very easy, right? P, Q, R. What is P here? P is diamond. Very easily we can identify. And Q is graphite. And what is R here? That is the lattice structure of sodium chloride. Sodium chloride. Right? So P, substance, diamond, and the lattice, atomic lattice. Atomic lattice. Both in graphite and diamond, we can find atomic lattices. Right? Then Q substance is graphite. Right? There are weak bonds between the layers. Right? These layers can slip over the other. That is why we use graphite as a what? Lubricant. Right? What is the reason for using graphite as a lubricant? If the question is like this, yes, how you answer? There are weak bonds between the layers of the graphite, layers of carbon, right? There are layers of carbon here, there are layers of carbon, then between these layers, there are weak bonds, weak bonds. So, these layers can slip over the other. That is why we use graphite as a lubricant, right? You have to give the reason and prove it. Then R substance is sodium chloride. And what is the lattice, Pute? That is ionic lattice. Ionic lattice. Second one, write the names of the chemical bonds labeled alpha and beta in the lattice structures. Alpha. Both in P and Q, alpha has mark. Yes, what is the bond? Covalent bonds. Covalent bonds. Beta means ionic bonds. Ionic bonds. Both in diamond and graphite, we can find covalent, and in sodium chloride, ionic bonds. Right? Of the substances P, Q, and R, which substance conducts electricity in the solid state? Solid state, in the solid state. Right? Why they specify that one? Solid state. Sodium chloride also conduct electricity, but is it in solid, Pute? No, that is wrong. In molten or aqueous solution. Molten or aqueous solution, ionic compound. So, if it is here, sodium chloride conducts electricity. But in the solid state, it conducts electricity only in graphite. It is a special thing that you have to remember. Right? In graphite, in the solid state, it conducts electricity. Right? If it is sodium chloride, in molten or aqueous solution, it conducts electricity. Right? Now, which substance has highest hardness? Which one, Pute? P or diamond. If you have written P, that is also correct. If you have written diamond, that is also correct. For the previous one also, Q or graphite, both are correct, right? Look at B. Given below are two reactions, right, in connection with the metal M. Right? M is not a standard symbol, Pute, right? M plus oxygen gas, when we heat it, and it forms a white color powder. Then, according to the second one, when M react with Y, it forms magnesium chloride, an aqueous solution, magnesium chloride, and a colorless gas. Yes. When M react with oxygen gas, it forms a white color powder. 4B part. Right? 4B part. M react with oxygen gas and it forms the X, and it is a white color powder. Right? They give a clue here, white color powder. Right? And when M react with Y, it forms what? Magnesium chloride. Magnesium chloride. I write like this. Magnesium chloride and a colorless gas here. Colorless gas. Right? If it forms magnesium chloride here, right? So M should be, yes, magnesium. M should be magnesium. Then if the salt is magnesium chloride, Pute, yes, this one should be what? HCl. HCl. Right? Then what is the colorless gas here? If we use HCl here, this colorless gas should be hydrogen. Hydrogen. Then M is, yes, magnesium. M is magnesium. Then M react with oxygen gas. It forms white color powder. What is that, Pute? That is magnesium oxide. What is this? Reacting M with oxygen means burning a piece of magnesium in air. Burning means it reacts with oxygen gas. Burning magnesium in air. What is the flame, Pute? Bright white color flame. Two observations there also. It gives a bright white color flame and the white color powder remain. White color powder means magnesium oxide. Then we can complete. M is magnesium and X is magnesium oxide and Y is HCl and Z is hydrogen gas. Right? In compound X, the ionic form in which M exists is M plus 2. M plus 2. That means here, M plus 2. Right? Write the chemical symbol of the ionic form in which oxygen exists in that compound. Oxygen in MgO, Mg2 plus ion, right? In magnesium oxide, right? To form magnesium oxide, magnesium removes 2 electrons and form Mg2 plus ion, and oxygen obtain that 2 electrons and forms O2 minus ion. So this is the other ion that forms here, O2 minus. O2 minus. Third one, X is sparingly soluble in water. Which color litmus papers give a color change when testing that aqueous solution with litmus papers, right? X means this one, no, this here, sorry. Magnesium oxide, Pute, right? When magnesium oxide dissolve in water, right, in the aqueous solution of magnesium oxide, when magnesium oxide dissolve in water, it forms magnesium hydroxide, right? We know it is a basic one, right? So what is the question is, which color litmus papers give a color change? Give a color change, right? When testing the aqueous solution with litmus papers. So which color litmus papers give a color change for the bases? Yes, red color, right? In bases, red litmus turns into blue, right? When we use blue litmus, no color change. So if you have written blue here, that is wrong, Pute. They have asked which color litmus papers give a color change. There should be a color change in the litmus papers, right? So we have to use red color litmus papers, right? In the basic solutions, red litmus papers turns into blue, right? So the answer should be red, right? Then look at the fifth one, right? Question number 5. It is a part of the one of the part of the essay question, Pute, right? From the sixth question, right? You know the sixth question is a totally chemistry one. This is one part of that, right? An apparatus set up by a student to collect scientifically measured volume of carbon dioxide gas using the method of downward displacement water is given below, right? Downward displacement of water, that is the collecting method of the gas. Right, the experimental setup is given, right? Dilute hydrochloric acid is allowed to drip on the pieces of calcium carbonate through the thistle funnel, and carbon dioxide gas is produced by the reaction between those two, right? Look at the first one, part 1. What change should be made in this setup to prevent the escape of gas produced through the thistle funnel? Right? Calcium carbonate pieces are they are in the conical flask, and we add hydrochloric acid from the thistle funnel. When these two reactants mix together, they start to react and they form carbon dioxide gas. Right? What is the question here is, what change should be made in the setup to prevent the escape of gas produced here? Yes, according to this one, Pute, right, the thistle funnel and the delivery tube is in the same level, right? So what happens here is, right, carbon dioxide, yes, carbon dioxide can release through the thistle funnel when we keep the setup in this way. So what is the question is, what change should be made? Yes, what we have to do? We have to lower the thistle funnel, right? Lowering the thistle funnel, right? That is dip in uh, HCl acid. Lowering the thistle funnel. You can write in words, or otherwise you can draw the diagram also, right? At that time, for the correct diagram also, the marks were given, right? No need to draw the whole diagram. No need to draw the whole diagram. Only you can draw this part, Pute. Right? In this way. Right? We have to lower the thistle funnel. Right? Lowering the thistle funnel, and delivery tube is there. Right? Somewhat higher than this one. Only draw this part. It is okay. Right? The thistle funnel. Lowering the thistle funnel. Right? Second one. What is the advantage of using small conical flask rather than large conical flask here? This one. What is the importance of using a small one? Yes. What is the answer, Pute? Right? So, when we use a small one, right, no need to use more reactants. If we use a larger one, we have to use more reactants because there is a large space here, right? After filling the space here with carbon dioxide, it's sent through the delivery tube, right? So, when we use a small one, right, only we have to use small amounts of reactants, right? That is one thing. And we can collect carbon dioxide gas, a sample of carbon dioxide gas with more purity, right? And also we can collect a sample of carbon dioxide gas with a short period of time, right? With a short period of time, because when the conical flask is small, right, the area inside the conical flask is less, right? When it fills the carbon dioxide in that area, right, then it's sent through the delivery tube, right? So then with a short period of time, we can collect a carbon dioxide gas sample, right? You can write one of those, right? No need of more reactants, or can collect a carbon dioxide gas sample with a short period of time, right? Because the volume is less in the conical flask. Yes. What is the third one? Write the balanced chemical equation indicating the reaction between calcium carbonate and hydrochloric acid. Right? Calcium carbonate and hydrochloric acid. You have to write the equation, Pute. Right? Calcium carbonate plus HCl. Calcium carbonate plus HCl. Right? It forms calcium chloride, yes, water, and carbon dioxide gas. Yes, to balance the equation, we have to put 2 here. Right? You have to write the balanced chemical equation. Right? No need to mention the physical states, right? If you did not write the physical states, the marks were given at that time, right? Look at the fourth one. If an equal mass of powdered calcium carbonate, right, Pute? Powdered calcium carbonate was used instead of the pieces of calcium carbonate, required volume of gas can be collected in a shorter period of time. When we use the same mass of calcium carbonate, right here, but in the powdered form, right, in the powdered form, within a short period of time, it can collect a sample of carbon dioxide. Explain briefly the reason for this. Explain briefly, then step by step you have to reason, right? Equal mass of powdered calcium carbonate was used. Yes, what happens here, Pute? In powder form, yes, in powder form, what happens? Surface area increases. In powder form, surface area increases, right? When the surface area increases, here's what happens. Number of collisions increases, right? They asked to explain briefly, Pute. So you have to write step by step. In powdered form, surface area increases. Because of increase of that one, number of collisions increases, so that reaction rate increases. So that reaction rate increases. Right? That is how you have to explain in brief with giving reasons. Right? To increase the reaction rate, if you are writing that the reaction rate increases, you have to give the reasons, Pute. Right? Next one. Fifth part A. Name another method, right? Name another method for collecting carbon dioxide gas used in the method you stated in part A above. Sorry. Name another method of collecting carbon dioxide gas when the measurement of the volume of the gas is not required. The volume of the collecting amount is not required. Only we have to collect the gas. Right? Yes. What we can use, Pute? Yes, we can use upward displacement of air. Upward displacement of air. There we use the gas jar in this way, right? Because carbon dioxide is higher denser than the normal air, right? So we put the derivative in this way to the gas jar, right? As carbon dioxide is higher denser, it goes down. Carbon dioxide fills here, right? And the air, that normal air goes up, right? Normal air goes up and carbon dioxide collected here. That is why we name that method, yes, what? Upward displacement of air. Upward displacement of air. Name another method. Upward displacement of air, right? Look at B. What physical property of carbon dioxide gas is made use of in this method you stated? What is the property of carbon dioxide we use here to collect the carbon dioxide by using this method? Yes, because carbon dioxide is higher denser than air. Carbon dioxide is higher denser than air. Oh, the question is what physical property? No, then what is the physical property? Pute? Density, right? Physical property is density. That if we write as a statement, carbon dioxide is higher denser than air, right? Then sixth one, state a test, right? That can be used in the school lab to identify carbon dioxide gas, and you have to write the observations also, right? From grade 6, we use the same method to identify carbon dioxide gas. What is that, Pute? Yes, sending carbon dioxide gas through colorless lime water. Colorless lime water, or you can write bubbling of carbon dioxide gas through colorless lime water. That is the test. And observations, colorless lime water turns into milky. Right? You have to write the observation clearly. Colorless lime water turns into milky. Right? State, next one. State an instance where non-combustible property of carbon dioxide is made use of. Right? Carbon dioxide gas is a non-combustible gas. When we consider oxygen, it is a combustible gas. Right? No, hydrogen is the combustible gas and oxygen is support for combustion. Right? You have to remember these people. Hydrogen is the combustible gas. Right? That is why we use what hydrogen as a fuel in rockets, because it burns and gives energy as a fuel. Right? And oxygen, it is a supporter for combustion. For combustion, three factors needed. Supporter for combustion, that means oxygen gas should be there, and there should be a combustible substance, and the combustible substance should be just heated up to ignition temperature. The three factors needed for combustion, right? You learn from grade 8, okay? Right? So, what is the instance in fire extinguishers? In fire extinguishers, carbon dioxide gas is used because it is a non-combustible gas. Right? Right. Then the last one. Right. Question number 6. That is again apart from the essay question. Right. Here that you have to apply the knowledge that you have learned for this one. Right. Otherwise, this setup or this instrument, it is not given in the book, Pute, but you learn these things. Right. A longitudinal section of a fractionating tower used for refining crude oil is given below. Crude oil containing in abundance are the compound X in the fraction released from the outlet 1. X released from the outlet 1 from the upper outlet. Compound Y from the outlet 4 in the middle, and compound Z from the outlet 6 at the bottom. Right? By what common name is the group of organic compounds contained in abundance in crude oil known? Right? By what common name is the group of organic compounds? Organic. Right? Contained in abundance in crude oil. Yes. What is that, Pute? Hydrocarbons. Hydrocarbons. Name the crude oil refining technique employed in the tower. What is this method, Pute? Yes, what is the method that we use to separate the hydrocarbons or the components in crude oil? Fractional distillation. Fractional distillation. Third one, the boiling points of compounds X, Y, and Z are Tx, Ty, and Tz respectively. Write them in the ascending order. Write them in the ascending order. The boiling points are given here. Right? We separate them according to their boiling points. Right? So, we have to write in ascending order. Sixth one, third part, Pute. Sixth one, third part. Ascending order. Tx, Ty, and Tz. X means the substance or the component that we extract from the first outlet, right? And Y is from fourth and Z from the sixth one, right? So, ascending order. So, the Boiling point is least in T, then Ty, and the highest one is Tz, ascending order. Then look at the fourth one. X is a compound with a single carbon atom and containing carbon and hydrogen only. Draw the dot cross diagram, not the Lewis one. Dot cross diagram of X molecule. X molecules, single carbon atom and hydrogen. Only it contains carbon and hydrogen. Right? Fourth one, Pute. Single carbon atom and only carbon and hydrogen. Right? Then there should be 4 hydrogen atoms. We have to draw the dot cross diagram. Dot cross diagram, not the Lewis. Right? 4 hydrogen atoms combined with 1 carbon. Dot cross diagram. Write the balanced chemical equation relevant to the complete combustion of 1 mole of compound X in the oxygen gas. This one, right, 1 mole. CH4 combustion means it react with oxygen. When hydrocarbons burn or when they react with oxygen, they form gas, carbon dioxide and water. Carbon dioxide and water. Yes, we have to balance the equation. Put it here, but we have to write relevant to complete combustion of 1 mole of compound X, right? 1 mole of compound X. Here there are 4 hydrogen. Then we have to put 2 here. Then 2 plus 2, 4 oxygen. Then we put 2 here also, right? 1 mole of CH4 combined with 2 moles of oxygen. 2 moles of oxygen, okay, right? We have to write for the 1 mole of CH4. That is okay, right? Then here that I have to mention another thing, Pute, right? When when hydrocarbons completely burn, right? What are the products form? Carbon dioxide and water. We can say water vapor, right? Carbon dioxide gas and water vapor. Then here also you have to know how we identify carbon dioxide gas by the same method and water or the water vapor. Yes, by using anhydrous copper sulfate. Anhydrous copper sulfate. What is the color of anhydrous copper sulfate? Yes, Pute, white color. When they absorb water vapor, that white color anhydrous copper sulfate converts to hydrated or hydrous copper sulfate. It is blue color, right? Anhydrous copper sulfate in white color, when they absorb water vapor or water, they converts to hydrated copper sulfate. Hydrated copper sulfate is in blue color, right? That is how we confirm these two, carbon dioxide and water vapor, that produce in burning hydrocarbons, right? Sixth part, Pute. The substance released from outlet 7, right? 7. The outlet at the bottom, right? Outlet 7 of the tower is used to construct roads. Name that substance. What is that, Pute? Tar, right? Tar, that is used to construct roads. Seventh one. State an environmental problem caused by the gaseous components that would be released to the environment during refining of crude oil. That means carbon dioxide gas, Pute, right? So we have to write the environmental problems related with carbon dioxide gas, right? Yes. What is the main one? Because of the high concentration of carbon dioxide in the atmosphere, it affects to the, yes, global warming, right? Global warming, that is one thing. And the photochemical effect, right? Photochemical effect, global warming, photochemical effect, and also acid rains, right? Acid rains. And here it is mentioned in the marking scheme, no marks for the greenhouse effect, right? Because As the greenhouse gases, we do not mention carbon dioxide, right? So as the effects of the high concentration of carbon dioxide gas, don't write greenhouse effect. You can write global warming, photochemical effect, and acid rains, right? These are in the grade 11, the last one, biosphere lesson, Pute, right? We will discuss it later, but up to now, you have to remember, right? So that is about the structured and essay papers, right? As I told you, there are some more questions, Pute, right? Only I have selected these things to practice you how to write the answers, right? How to write the answers. So always try to write the direct, clear answer, right? Most probably you have to give reasons, right? Then very easily you can get marks, right? So that is about the chemistry part, Pute, right? Then next day, right? Next day, we will try to do the physics questions, right? Physics question from the O-level past papers, right? From 16 to 22, right? There are some more questions that before 2016 also, right? If they are regarding with the syllabus, I will get those questions also, right? We will see, right? Anyway, right now we have complete the whole chemistry part, and we practice some questions, and also we answer the past paper questions also, right? That now you know, right, what is the state now you are in, whether you can answer the questions or not, right? So you have to think that what you have to do, right? Whether you have to practice more and more, or whether you have to go through the theory parts again, like that, right? So as I told you, right, if you want to do something or any change in the class, please tell me it, Pute, right? That with the December, right, if the exam is in May, right, we have 6 months, right? And we have to cover the grade 11 syllabus also, right? We have to practice more questions, right? After completing these past paper questions, right, I hope to do some test, right, regarding the grade 10 syllabus, right? Grade 10 syllabus. So we have to complete the other two sections, physics and the biology, right? So I will send the paper, right? And they are the in the physics section, you have to do many more calculations, right? So practice those things, right? So then we will stop for today, right? Then thank you very much and good night.
Good night, teacher.
Yeah,
Thank you, teacher. Good night.
okay.
Thank you, teacher. Good night.